Okay, so moving on to section 3.4, this is called present value. Present value is essentially paying back a loan, right? You borrow money, you have to pay it back. So let's start with the formula. Present value, PV equals PMT, and then a big fraction, 1 minus 1 plus I to the minus n over I. And these are some very familiar letters and variables here. This formula, like the future value formula, you don't have to memorize. You'll be given this on various tests. What are the variables? PV is the present value. That's how much you borrow, how much you have to pay back. Payment, PMT, are the payments you make, right? These are a stream of payments, monthly, weekly, yearly, something like that. I, as in the future value formula, is interest rate per period. And if you think back to the compound interest formula, I is R over M. And N is the total number of payments. And what is that? Thinking back to the compound interest formula, M times T. So M is the number of payments per year, T is the number of years, and that, multiply them together, that gives the total number of payments. Okay, so that's the formula, right? And the problems in the book then and on the worksheets and everything are just applying this formula to different cases. And so the goal then is, this is the formula, these are the variables. Can you figure out which variables go where and which one you need to solve for? So talking about some of the problems in 3.3 in the book, problems 1 through 8, those are just find I and N. Pretty straightforward. It's the same as in chapter 3.3, the opening problems there. Problems 9 through 14 are find one variable given the other three. So two of these types of problems would do a lot of, right? When you're given the present value, can you find out the payment? In other words, if you know how much you borrowed, how much do you have to pay back each month? And the other one is if you know what your payment is, can you figure out the present value? So we'll do one problem, which is solving for n. That's a lot like actually problem 18, where they ask you to explicitly solve the equation for n. And problems 23 and 24, this is solving for the present value, and most of the rest of the problems, I think this is most of them, 38, 41, and 42, are solving for payment with some twists along the way. So these are the ones that we're going to look at in this video, and I'll do it in a table problem for amortizing a debt in a separate video. So let's look at an example. Suppose your present value is 35,154.59. Your payment is 550, and I is 0.04 over 12. Can you solve for n? So this is one of the problems between 9 and 14. It's also like problem 18. So what's going on here? Present value, you've borrowed this much amount. You're making these many payments at 4% compounded monthly, right? So that's what the 12 is. So how many payments do you have to make to pay back this amount? And so we plug in the formula. And so the formula is PV equals payment, horizontal line, 1 plus I to the minus n is my numerator, I is the denominator, the thing in the bottom. So you just plug everything in. 35,154.59 equals payment is 550. 1 minus 1 plus 0.04 over 12, which I'm just going to leave like that because I don't like having lots and lots of decimals floating around. Minus n, and that's what we need to find because we don't know what that is, all over I, which is 0.04 over 12. So, to clean this up a little bit, I'm going to multiply both sides by 0.04 over 12, and that'll get rid of my denominator. And I'll divide both sides by 550, and that will get rid of this 550 floating around. So 0.04 over 12, divide by 550, 35,154.59 equals, well, divide by 550 gets rid of this, multiplying by this clears out my denominator, so 1 minus 1 plus 0.04 over 12 to the minus n. And this whole mess on the left you can plug into your calculator. 213.05812 is this thing. And note, our minus n is in the exponent. So how do we get things out of the exponent? We'll have to use log rules. And in particular, ln a to the b equals b ln a. That's our favorite log rule here. Okay, so if I move this over to the left side and this over to the right side, we get 1 plus 0.04 over 12 to the minus n equals 0.786942. And note, a negative power can come down, means put everything down in the denominator with a positive power. So I can rewrite this part as that, and that equals this. And this, of course, is a number, and numbers you can always think of 1. And so if I flip both of these fractions, I can still keep my equality. So think of it as just taking both sides to the minus 1 power. And so what do I get there? I get 1 plus 0.04 to the 12 to the n equals 1 over 0.786942, which is the same thing as 1.27074. Well, there's a lot of decimals in this anyway. But now we're at a point we've got something, that's this, raised to a power, and that should be nicely written n, equals some number. So now we can take the log of both sides. I like to do the natural log, but you can do whatever log you want. You can do log base 10. Probably don't want to do any other base because you don't have that on your calculator. And so we have that. And now log base to a power, the n, the exponent, can come out front, and log of 1 plus 0.04 over 12 equals log of 1.27074. And at this point you actually just find the logarithms of both sides, that you find the logarithms that are involved, this one. So log of 1 plus 0.04 over 12 is 0.0033278 equals, and log of 1.2704 is 0.2396009, and probably more numbers. And so we can solve for n. Just divide both sides by this, and you get 71.995, lots of numbers. So why didn't we get a perfect integer here? Well, because we've been rounding off all the way through. N equals 72, or 6 years. So 72 payments, but we're doing monthly payments, so 72 payments at 12 a year means you'd do paying for 6 years. So we go all the way back up, right? And what was n? The number of payments, 72, took us 6 years. So remember, if you're looking for n or t in these problems, it's in the exponent. You have to use a log rule, and that's these things. How do you do a log rule? Well, you have to isolate the base raised to the power all by itself, and then you can use the log rule on both sides. Okay, so problem 18 is a lot like that. It's asking you to solve for n. It's, follow the same procedure, except instead of using numbers, just use this formula and solve for n. Okay. So That's one problem. Problems 23 and 24. These are solving for the present value. And so a particular problem is you can get a 4-year loan. That's a year. Let me write that at least a little coherently. Loan at 7.6% interest, compounded quarterly. And quarterly is 4 times a year. You can afford $750 a month. No, a quarter. Sorry, quarterly, not monthly. So you can afford $750 quarterly payments. Okay, so how much can you borrow is one question. And the other question that we're often interested in is, how much do you pay in interest? So you can make this level of payments, $750, and you can borrow some money, you know, and you pay it back, $750 every quarter. How much can you actually borrow? How much will they lend you for that? So, present value, payment, I, and what are these things equal to? Well, in this problem, we're dealing with 7.6 compounded quarterly. So I is 0.076 over 4, which is 0.019. And 4-year loans, quarterly payments. So how many total payments will you make? Well, 4 years at 4 payments a year, that's 16. How much can you pay? $750. What's the present value? We don't know. So we need to find the present value if you know the other things. What's the formula? Present value equals payment times 1 minus 1 plus I to the minus n over I. Plug everything in. 750 times 1 minus 1.019 to the minus 16 all over 0.019. So be careful with your calculator when you're doing this, because there's a lot of sort of parentheses here. Remember the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction, right? So 1.09 to the minus 16, you have to do that first, and then 1 minus that, and then divide by the 0.019, and then multiply by the 750. And note that this thing in the middle is 1 plus I, so 1 plus 0.019 is this. And so, what's your present value? Well, once you figure out this number in the brackets here, it's about 13.6859. You multiply that by your payments, and so the present value is 10,264.41. That's how much you can borrow. How much interest do you pay? Well, this is how much you borrow. What are your total payments? I don't need to write that all. So total payments, oops. So how much did you actually pay overall? Well, you made 16 payments of $750, right? So N times your payment, that's how much you actually paid. So here, that's 16 times 750, and so you ended up paying $12,000. How much did you borrow? Well, you borrowed this much, right? So the present value is how much you actually borrowed. So this is how much they lent you. So what's the interest? Well, you paid back this much, but this is how much you borrowed, so the difference is the interest. Okay. So you pay back the loan itself, which was this amount, plus this interest, and that's the $12,000 that you paid back. Okay, so interest then is the total payments minus, oops, there's my watch going off, total payments minus the present value. Okay, so if we're solving for how much you can borrow, that's solving for the present value. If you know all the other variables, you just plug everything in and see what the present value is. Solving for payment is also fairly straightforward. So one example along these lines is, so this is looking at problems like 25 through 30. 25 through 30. You want to buy a car. So you want to buy a $20,000 car. The dealer says 0% financing, which just means you just make monthly payments and there's no interest on it, or a $3,000 rebate. Right? So they can give you $3,000 off the car, or they can give you 0% financing. The bank, you go and talk to them, and what do they say? Well, they say, we'll loan you money. You've got a good enough credit rating. We can loan you money. 60-month loan at 3% compounded monthly. And we should note here, which I forgot earlier, the 0% financing is for 60 months. Okay, so what should you do? Should you take the 0% financing, or should you take the rebate and get a loan from the bank? Well, how can you tell? Well, it depends, right? What are the payments? If you take the 0% financing, well, then you make, oh, I'm sorry. I'm going to change the value of the car so that the numbers come out better. 20,100. If you go to the bank, no, it's supposed to be 20,000, sorry. If you go to the bank, 0%, if you take the 0% financing, right, what are your payments? Well, you have to pay back $20,000 over 60 months. So you make 60 payments to get through the $20,000, and that will be 333.33. It should be just endless 3, but we'll round it off to that. So $333.33 dollars per month for 60 months, and that'll pay off the car. What about the bank? Well, how much do you have to borrow first? If you take the $3,000 rebate and get a loan from the bank, you only have to borrow $17,000. And if you borrow $17,000, what are your monthly payments? Right? And if the payments are more than 333.33, then go to the bank. If the payments from the bank are more than 333.33, then take the financing. If the payments from the bank are less than that, then go with the bank. So what are your payments from the bank? Well, we know a formula for that. And these are the 4 variables that we need. I need to borrow $17,000. My interest rate is 3% compounded monthly. So 0.03 divided by 12 is 0.0025. And N, well, it's a 60-month loan, and you make monthly payments. So you make 1 payment a month for 60 months. So you make 60 payments. And what are the size of the payments? We don't know. So present value is payment times, here's the formula again, 1 minus 1 plus I to the minus n over I. And if you plug everything in, it becomes 17,000 equals the payment, which we do not know, 1 minus 1.0025, that's my 1 plus I, to the minus 60 all over 0.0025. And if you grind out this thing in brackets, we find that 17,000 equals our payment times 55, 65, 24. So this number here, 55.6524, that's this thing inside the bracket if you calculate that. So what's our payment? Well, 17,000 divided by this thing, and that means that 305.47 is your payment. Right? So 0% financing gets you $333.33 as your monthly payment. Borrowing from the bank, 17,000 from the bank, that means 305.47 is your payment. That's cheaper. That's better. So in fact, how much do you pay for your car if you go to the bank? Well, how many payments do you make? You make 60 payments times 305.47, because that's the size of each payment. And what's that equal to? 18,328.20. So you borrow 17,000, you pay back this much. So how much you go over 17,000 there, right? The 1,328.20, that's your interest. But even borrowing that money plus the interest, that's still cheaper than the $20,000 that the dealership is charging you. So cheaper to go to the bank there. Always good to shop around a little bit when you're buying a car or anything, in fact. Okay, so 38, 37, 38. One of these is like buying a sailboat. Keep in mind that if you pay 20% down on, say, for example, a $35,000 sailboat, how much do you actually have to borrow to buy your sailboat? Well, you only borrow 28,000, right? You don't borrow the whole 35,000 because 20% of 35,000 is 7,000. So that's the 20% you put down. And then you only have to borrow 28,000. So it's very much like in the car example here. You don't have to pay the whole 20,000 because they give you a $3,000 rebate. You only have to borrow 17,000. Okay, now there's a little bit of a twist in 41 and 42. These are also very similar, looking for payments. We're also looking for equity. So buying a house, what is your equity after, say, 10 years? So what's going on with equity? Well, you buy a house, you get a mortgage, you pay money back, you make monthly payments back to the bank. Some of that payments are interest. Some of those payments are actually paying down the debt on the house. It's actually buying your house. So after 10 years, how much you've actually bought back from the bank for the house? So let's pretend we're rich for a moment and say you've borrowed $1 million, like Dr. Evil, $1 million, 1 million, 6 zeros, for a house. And the mortgage you've got in this borrowing with a 30-year mortgage, which is pretty standard for mortgages. 30-year and 15 years seem to be the standard periods. 30-year mortgage at 4.8% compounded monthly. And we want to know a bunch of things. Oops, monthly. Right. What are your payments? And of course, how much do you pay? Question mark. And then of course, how much is interest? also want to add a couple of other questions. What's your equity after equity? Let's spell that correctly. E-Q-U-I-T-Y after, say, 10, 15, 20 years. How much have you actually paid into the house after 10 years? So the equity is what you get after you sell the house, right? If you want to sell the house after 10 years, you haven't paid off the mortgage. So when you sell the house for your $1 million, you have to pay back off the bank, and then you keep whatever is left. And that's your equity, is whatever you get to keep. So for this problem then, what's my present value? Well, present value, payment, IN, these are the things that we always want to know. Present value is $1 million, right? Payment, we don't know that because we're actually looking for that. What are your payments? I, 4.8% over 12, a convenient 0.004, and then 30 years, 12 payments a year means you're making 360 payments all told. Okay, so present value is payment times 1 minus 1 plus I to the minus n all over I. We put a big bracket around that. This is the number that you need to sort of calculate with. If we're plugging the numbers, what do we have? We have $1 million for our present value. Payment, we don't know that. And then we look inside our square brackets. We got 0.1 plus 0.004 raised to the minus 360 all over 0.004 in a bracket there. So we calculate what this thing inside the square brackets is. We get 1 million equals your payments times 190.5977, more or less. There are more digits after that, of course. So your payments, divide $1 million by this, and you get 5,246.65. Those are your payments each month. Okay, so you make 360 of these payments and you'll have your $1 million house bought. So what are your total payments? How much do you have to pay back in total? Well, N, you make 360 payments of this size, so 360 times 5,246.65, that's 1,888,744. How much did you borrow? Well, that's the present value. That's the $1 million you borrowed from the bank to be able to pay this, buy this house. And so what's the interest? Well, total payments minus the present value, 888,744. Almost the entire value of the house, right? You almost pay the entire value of the house in interest. So 30-year mortgages, you can pay a lot in interest sometimes. So great. So there's our total payments, how much we borrowed, what the interest is, what our payment is. Suppose we want to sell the house after 10 years. And of course we sell it. It's $1 million house, so we sell it for $1 million. So how much do we have invested? You've paid, or we've paid, whoever it is who's doing the paying. So you've been paying the bank for 10 years, and each payment covers interest and some debt reduction, right? It's actually buying down the house a little bit. So how much do you have left to pay? If you sell for $1 million, how much is left to pay? How much do you have to pay off the bank for? Well, there's 20 years of payment left. And that's at I equals, at, what was I, 4.8% per month, or compounded monthly. So how much is this actually worth? Right, 20 years of payments of $5,246.65 at 4.8% a month. Well, that's a present value problem, right? How much in the present is 20 years of these payments worth? So we set up the same problem, and a lot of it doesn't change, right? I certainly doesn't change. That's still 0.048 over 12, which is 0.004, but n now has changed. It's 240 payments. And how many payments do you make? How much do you pay for each payment? $5,246.65. And what's the present value? Right? So if we want to know how much is left on a loan, you just calculate the present value for the payments on the loan with the number of payments left. And so this becomes, again, present value equals, I'm not going to write out the whole formula, but it's 5246.65, that's my payments, and then we have 1 minus 1.004, that's still my 1 plus I, but now it's to the minus 240, not to the 360, because there's only 20 years left of payments left, divided by 0.04. And so the present value is, where is that? 808, 473.63. This is amount left to be paid to bank, right? So what's your equity? Well, that's the $1 million selling price minus how much you have to pay to the bank to pay off the loan. And so what's your equity after 10 years of working in this, of paying off this house? It's $191,526.37. So you've been paying for 10 years on $1 million house, and you've got, when you sell the house, this much money you have to give to the bank to pay off the mortgage, and you get to keep this, $191,526.37, about 19% of the cost of the house, right? So you're in this for a third of the years of the mortgage, right? It's a 30-year mortgage, you're a third of the way through it. You've been paying for 10 years, but you've only 19% of the house that you own, not 33%. So in fact, this is what you'd have left if you actually sold the house. It's an important thing to keep in mind about loans, is that when you pay back loans, the first third of it is actually mostly paying back interest. So what about after 15 years? What's your equity after 15 years? Well, it's the same deal. To find out how much is left on the loan, you find the present value of the payments for 15 years. And so we set up pretty much the same thing as this up here. Present value, payment, I is still 0.04. Your payment is still 5246.65. But 15 years, that means there's only 180 payments left. So what's your present value? And if you do the same calculation as we did here, plug everything in, but now use minus 180 instead of minus 240. After 15 years, the present value is 672,290.23. What's your equity? Well, if you sold the house for $1 million, this is how much you have to pay back to the bank, the present value. So the equity is whatever's left over. So it's $1 million minus this present value. So 327,709.72. When you're halfway through the mortgage, you only own about 1/3 of the house. And then it picks up in the back half of the loan. So what's your equity after 20 years? Right. Now N is only 120 because after 20 years there's only 10 years left of payment, so there's only 120 payments. If you calculate the present value as we did there, the present value is now 499,250.06. That's how much you owe the bank if you sell the house. So what's your equity? Well, if you sell the house for $1 million and you have to pay this back to the bank, then your equity in the house is how much you get to keep, which is $500,000, 500,749.94. God, talking for this long makes my throat dry. Great. Important point though here at the end of the road, 2/3 of the way through the mortgage, you've paid off half of the house, right? So it takes you 2/3 of it to pay off the first half, and then the last third pays off the last half. Bailing on a mortgage early, you end up paying mostly money into the bank in interest. It's in the last third of the loan where you actually pick up the most money, the most equity in the house. So after 20 years, you've got about $500,000 invested in the house. After 30 years and 10 more years, you pick up another $500,000 and you have your $1 million house free and clear. Okay, so that's present value. There'll be one more video involving Microsoft Excel on amortizing debts and setting up an amortization table for mortgages, and we'll see, we'll be able to look at how quick